Right, this is module 2. I'm Shivam, and let's start. So let's start out with what's moderation. So moderation is when an independent variable is moderated by a moderator variable, such that there is a additive effect, such that there's a compounded effect on our dependent variable one way or the other. Now, it's represented in the form of this equation, such that B0 and B2 are your intercepts, and B1 and our B3 are our slopes. So these kind of account for differences in the slopes and differences in the intercept. Now, as such, and E, of course, stands for the error. Now, as you can see here, like, this is pretty complex. So, and to model this would be slightly difficult. So in order to simplify that a little bit, we use simple lines and slopes, and turn this initial model to one which is familiar to us, which is our bx plus b0, and this entire section functions as b0, and this entire function this entire section functions as bx. What this allows us to do is it allows us to kind of model this aligned with the regression that we've come to know and love. And that's what I've done exactly for the moderation models. Just before we get into that, few facts. We have used one continuous and one categorical variable across all three models. All input variables were centered such that their means were 0, and all the main effects were found to be significant. And I've not put that here, but all our effects between x and y were found to be significant at when I checked it initially. So these are the specifics of each model. Here we can see that when I'm saying insignificant and significant, we're talking about if B0 is equal to 0 or 1, depending on what we've put. So in this case, it's equal to 0, and in this case, it's equal to 1. So like it's significant means it's more than 1. Okay, right. Thank you. So moving on, we're going to go to the next section, and we're going to see that model 1, our intercept B0 and our slope B3 are insignificant, whereas slope B1 and B2 are significant, which this is what we've kind of predicted, and based on the model we've generated, we can see a lot of similarities between what we've predicted. So for 1, we can see the intercept change as predicted. So initially our intercept was 0, which is kind of moved to 1, and although we have a positive slope for our initial effect, our moderation effect actually has no change in overall slope, and that's actually visible through our regression, through the regression coefficients and the check as well. Here we can see that the intercept is not so different from 0, and so is our interaction effect not so different from 0. Going on to model, just looking at the diagnostics, here we can see that our residuals are normally distributed. There doesn't seem to be much systemic bias in the way that we've gotten our measurements, and at the same time we have no influential outliers. Let's deal with model 2 as well. So here we can see that we predicted that there are both our intercepts would be our second intercept would be not different from 0, and everything else would be significant, and that's what we see here. We see a change of slope. We see that both the lines go through the same intercept, and we also see that our initial intercept is greater than 0, and our model actually reflects that as well. It shows that for x2 model 2, for this aspect of it is 0 and is not so significant. All our other variables and even our interaction effect, all our other predictors and our interaction effect is significantly different from 0 at the 0.001 level. Our diagnostics represent, it shows that our findings are fairly blue. Okay, so here we've used all both our intercepts and both our slopes are significant, and that's what we can see here. There is a change in our intercept and there is a change in our slope. And what we can also see here is all our findings, both our predictors in terms of the independent variable, and our moderator, as well as the interaction effects, are significantly different than zero, along with our intercepts. And here we can see that based on our diagnostics, they are fairly blue as well. So some issues for us to consider when we're looking at moderation is that there is a reduced power, and that's mainly due to the hierarchical nature of these effects, of the testings of these effects. And it usually means that because of the shared variances, by the time the variance has been allotted to the interaction effect, it has lost a lot of power, mainly with reference to effect size. And and what also occurs is a compounding in the effect of our measurement error, simply because what we're dealing with is a multiplicative effect as opposed to an additive effect. So if we have errors in our model, it really shows, and it really throws things off. Another thing is multicollinearity that can occur, but what we have strategized to counteract that is we've centered all our predictor variables. Now let's move on to mediation. So with reference to mediation, what mediation states is that the route to a independent the route from a independent variable to an independent variable is mediated by a proximal mediator, such that this mediation or this indirect effect better describes the relationship between x and y than the direct relationship between x and y. And when there is a significant effect, when there's a significant indirect effect, and when there's just a small or just a minuscule direct effect, well, that's partial mediation. But when there's no mediation effect, when there's no direct effect, and when there is a strong mediation effect, well, that's complete mediation. Now, the difference between mediation and moderation is that mediation was actually set up to be a causal and temporal model, such that x precedes m and m precedes y. So it is slightly sequential in its nature, but that's how Barron and Kenny put it. Modern social sciences definitely do use the term indirect effect and say that the temporal nature of these relationships is a matter of the way that we've designed our research studies, and it is not a statistical matter per se. So let's start out with the models, and what we're going to do is we're going to jump right into our Barron and Kenny 4 steps, as surmised by the webpage that was shared with us. So here we can see that our y and x, our independent and dependent variables, are significantly related. So there definitely is a direct effect on C. Our C line is direct. What we're looking at now is to see if there's a relationship between our mediator and our mediating variable and our independent variable. And here, as we can see, that there is a relationship which is not different, which is different than zero, and we can look into it further. Based on step 3 and step 4, what we're ideally looking for is two things. We're looking to see if our mediator predicts our outcome variable, which it does. Our mediator does predict our outcome variable. And then we're also looking to see if, now that the mediator does predict the outcome variable, is there a direct relationship between x and y? And here we can see that there is a significant relationship between X and Y, which means that this is partial mediation. Right. So the Sobel test is a Z test, which we usually use, which describes just the mediating relationship, and it kind of qualifies that by the use of a Z test. And here we can see that there is definitely, based on our p-values, we can see that with a high degree of comfort, we can say that we have failed to reject that there is no relationship. Sorry, we have rejected that there is no relationship. With reference to our indirect effect, here we can see that it is significant based on our bootstrapping. Bootstrapping is when we increase the overall number of samples that we use, such that we have a robust and a complete understanding of the overall spread of our residuals. And the reason we do this is basically because our Sobel test and the Baron-Kenny steps that they've suggested actually have a pretty low power. So in order to have a look at a high power tool, we use bootstrapping. So here we can see that the indirect effect is significant, and so is our direct effect, which is another case for partial mediation. Now we're going to have a look at one where there's complete mediation, and here we can see that our mediating variable our X variable and our Y variable are significantly related here. And now what we can also see is the mediating variable M and X are also significantly related. With reference to step 3 and step 4, what we can see is our outcome variable is significantly related to our mediating variable, but with reference to now the relationship between X and Y is not significantly different than 0, which states that this is a complete mediation model. And our Sobel test qualifies the fact that there is a significant mediation effect at play here. Lastly, our indirect effect is known to be significant at the 0.001 level, and our direct effect is not significantly different than 0, and that is another case for our complete moderation. With reference to diagnostics, I did run diagnostics for model 2, although we can see that our residuals are slightly skewed. They lose normality towards the end. They are more or less normally distributed, although we have a slight amount of curve as a result of the measurement we may use, the measurement tools we may have used. It's more or less normally distributed, more or less randomly distributed, and our Cook's distance shows that we don't have any especially influential outliers. So that's my module 3. Thank you so much.